In this lecture, we're going to learn about pure virtual functions and abstract classes. And pure virtual functions are a mechanism we have in C++ to mean that the method isn't meant to be implemented in the base class. Here we have a simple inheritance hierarchy to try and drive this home. The base class is shape, and we are deriving from this class to create a circle class. And on the other side, we are deriving to create a rectangle class. If we look in the shape class, we have two virtual methods. One is going to be used to compute the perimeter of the shape. The other is going to be used to compute the surface of the shape. But if we go down in our inheriting classes, we're going to see that we have the same methods. These are going to be overrides of what we have in the base class. But the special thing about this inheritance hierarchy is that we don't have implementations for these methods in the base class here. And this is by design. If you think about it, this is an abstract shape. We don't know if it's a rectangle. We don't know if it's a circle. We don't know if it is a triangle. So we don't really have concrete information we can use to properly compute its perimeter and its surface. So it makes sense to really leave in the declaration for these methods, but leave the implementation details to inheriting classes, because these classes are going to have concrete information we can use to reliably compute the perimeter and the surface, and we can get this information here. So in C++, we mean this kind of design by setting up these methods as pure virtual functions. And what this is going to tell the compiler is these methods are not meant to be implemented in the base class. They are meant to be overridden and implemented by inheriting classes. And another side effect of this is that the compiler is going to prevent you from creating objects of this class, because it really doesn't make sense to create an object of shape in your design if you want to be able to compute its perimeter, if you want to be able to compute its surface. So why bother creating an object that you won't really be using in your C++ program? The meaning for this base class is just to be an idea or a representation of a shape without really going into the concrete implementation of how that shape really works. Hopefully this makes sense. So let's see how we can do this in code. Here we have a simple class, which is going to be our shape class. We are going to have two virtual functions. We're going to have the perimeter function. We're going to have the surface function. These are going to be virtual functions, or virtual member functions, I should say. But we are going to make them pure virtual functions by using the syntax you see here. So we're going to prepend n equals 0. And this is going to tell the compiler that these are pure virtual functions. Once you set up these functions, a few things are going to happen in your class. This class is going to become an abstract class in that you want to be able to create objects of this class anymore. If you try to do that, you will get a compiler error. Another thing is that you don't need to put in implementations for these methods because you marked them as pure virtual. And what this means is that the implementations will be put in by inheriting downstream classes, because they will have concrete information to compute the perimeter or the surface as we have here. So we don't need to bother with definitions for these functions here. If you even try to put in a definition here, you're going to get a compiler error, because this is a virtual function. We have no business putting an implementation in the base class here. These are meant to be implemented by downstream inheriting classes. Okay, once we have our shape class and our inheritance hierarchy, we can try to run this in our code. For example, if we try and create a shape object, we're going to get a compiler error because shape is an abstract class, so we can't create objects of it. And I don't think I made this super clear. Once you set up at least one pure virtual function in your class, the class is automatically going to become an abstract class. And what that means is that you want to be able to create objects of this class. So this is an abstract class we have here. And if we try to create an object of it, as we are doing on this line here, this is going to give us a compiler error. But we can still use a base pointer to manage a derived object a common setup we do with polymorphism. So for example, here we can set up a shape pointer and use this to manage a rectangle object. If we call the surface member function on our base pointer, this is going to do a polymorphic call, and we will get the surface of the rectangle, and we're going to print this out here. You're going to see that this is going to work. We can also use the base pointer to manage a circle object as we see here. If we call the surface method, this is going to do polymorphism, and it is going to call the surface version of the circle class, and we can see it printed out here. This is the design we can achieve. Even if shape is an abstract class, we can't create direct objects of shape as we are doing here, but we can use a base pointer or a shape pointer to manage derived object through polymorphism. And you need to be aware of this. Okay, now that you have an idea about what a pure virtual function is and what an abstract class is, let's see a few ideas you need to keep in mind. If a class has at least one pure virtual function, it will become an abstract class. You already know this. You can't create objects of an abstract class. If you try to do that, you will get a compiler error. Another thing I don't think I made super clear is that derived classes from an abstract class must explicitly override all the pure virtual functions from the base class. If you leave in any pure virtual class that you don't put in an implementation in for, your derived class is also going to become an abstract class, and you won't be able to create objects of it. You need to keep this in mind. Another thing you can't do, you can't call the pure virtual functions from the constructor of the abstract class. If you do this, you're going to get a compiler error because we don't have implementations for these things. So this is not going to work. The constructor of our abstract class is used by deriving classes to build the base part of our derived objects, but they are not meant to be used from the outside because we can't really create an object of an abstract class. So now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is Pure Virtual Functions and Abstract Classes. We are going to grab our template files and put them in place, and we're going to paste them in this project here. And we are going to grab the files that make up our inheritance hierarchy. You are going to get these files from the resource section of the course. If you want, you can download them and use them like I am using them here. Or even better, you can type the code and see how these things really work. That's the best way to learn. I do recommend that. But we want to save on time here, so I am just going to reuse these classes that I have lying on my drive. I am going to open this in Visual Studio Code by dragging and dropping here. We have our shape class here. This is going to be our base class. You're going to see that we have our member variable, which is going to be the description for our shape. We have a bunch of constructors here, but the most important thing here is that we have a bunch of pure virtual functions here. And if you go in the CPP file, you're going to see that we don't have implementations then for the perimeter and surface functions. These are pure virtual functions, and we have no business putting in an implementation in the base class. Once we have these virtual functions in and mark them as pure virtual functions, by prepending n equals 0 here, this class here is going to become an abstract class. And what that means is that we can't create objects of this class. It is meant really to be inherited from, and downstream inheriting classes are going to be forced to override these methods here. Otherwise, they are themselves going to become abstract classes. We're going to have a chance to look at this here. We also have our rectangle class, which is going to be inheriting from shape. It is going to override our two methods. We're going to override the perimeter function. We're going to override the surface function. For rectangle, the perimeter is computed this way. We're going to multiply the width by 2 and the height by 2, and we're going to add these two things up. We're going to compute the surface by multiplying width and height, and this is going to give us the data we want. We can look at circle. It is going to also inherit from shape, and it is going to override our methods here. If we want, we can even put in a radius and a variable to keep track of pi. We can do this. You can really do this however you want. This is just going to allow us to compute the surface relatively easily in this class here. Let's look at the implementation. Nothing special here. This is just going to forward the construction of the base part of us to the base constructor, and this is going to do whatever it is we want to do here. Let's head over to the main CPP file and actually use these things. We are going to include circle and rectangle. Let's do that. Circle.h, and we're going to put in rectangle.h, and we're going to first try and create a shape object. Let's do that. We're going to say shape and say shape pointer, and this is going to be new shape. We can use a default constructor, and if we do something like this, you're going to see that we're going to have a compiler error here. We have a squiggly line, but if we bring up a terminal window and look at the problems tab, we're going to see that object of abstract class type shape is not allowed. So shape is an abstract class now. And why is it an abstract class? Because we have at least one pure virtual function here. We actually have two, and this is going to make our shape class an abstract class. What that means is that we can't create objects of this class, and if we do that, we're going to get a compiler error. Let's try and build this program. We're going to pass this through GCC, our favorite compiler. We are going to see that the build is going to fail. We're going to have a bunch of errors. If we go up and look at the error we have, invalid new expression of abstract class type shape. So we can't really create an object of this. Let's go down and see what these errors are saying. Note, because the following virtual functions are pure within shape, and they are going to try and really be helpful in the errors that they give here. And all they are saying is that we can't create objects of this class because we have pure virtual functions inside. Okay, now you know this. If a class is abstract, you can't create objects of that class, but you can still use a base pointer to manage derived objects of that class. So let's comment this out, because this is going to make our code not compile, and we're going to say that this is going to give us a compiler error, and we're going to try and use a base pointer to manage a rectangle object. We can do this. So we're going to set up a shape pointer, and it is going to be managing the memory of a rectangle object. We're going to go through the base pointer and call the surface method, and this is going to call the implementation in rectangle because our base pointer is really managing a rectangle object. If you want, you can even use the type ID operator to print the dynamic type of this shape rect pointer. You're going to see that it is managing a rectangle. You can actually do this because we learned about that in the last lecture. So let's practice that. We're going to say dynamic type of shape rect, and we're going to say type ID, and we're going to dereference the pointer. We're going to say shape rect, and we're going to print the name of this, and we're going to see it print out on our PowerShell window. And after this, we are going to print the surface that we got from this call here, and we're going to see what this gives us. Let's try and build this program. We're going to pass it through GCC, our favorite compiler. The build is going to be good. We're going to clear and run Rooster. We're going to see that the dynamic type is rectangle. You can see that right here. So the base pointer is really managing a rectangle object, and this is what we have here. And if we call the surface method, we will be calling the method on the dynamic type. So we will be calling this surface method on the rectangle class, and we will be using the implementation we have here. So the surface function that is going to be called is what we have on line 20 in rectangle here. And this is going to just be a multiplication of width and height, and we're going to get 100 here because our width and height happen to be 10 and 10. So multiplying this is going to give us 100 as we see here. This is really cool. This is what we expect. We can even use our base pointer to manage a circle object. So let's do that. We're going to put in a separator to be able to follow this easily in our output. So let's say stdndl here, and we're going to put in the code. So we're going to set up a base pointer, which is really going to be managing a circle object here. And we will call our surface method. This is going to call this method polymorphically because surface is a virtual function. So we will get polymorphism here, and we will call the surface method on the circle object, which is really our dynamic type. If we print this out, we're going to see the surface printed out. But if we want, we can even print the dynamic type of our base pointer here. So we're going to do the same thing we did for rectangle. We can use our type ID operator to print the dynamic type of shape circle. And we're going to say shape circle here. And this is going to do what we want. Let's look at this. We're going to be printing the surface here. This is exactly what we want. So let's build and run. We're going to pass this through GCC. The build is going to go through as you see here. If we clear and run Rooster, we're going to see that the dynamic type is now a circle. So the base pointer or the shape pointer we have here is really managing a circle object polymorphically. So if we call a virtual function on this base pointer, it is going to call the most specific implementation of the surface object we have, and that happens to be for this circle object here. This is what I mean. If we compute the surface, we're going to see that it is going to be using the data we have here, and we will get this number as our surface. If you plug this in, you're going to see that this is really right. So this is really all I had to share in this lecture. We can set up pure virtual functions in our base class, and what that's going to do, it is going to make our class an abstract class, but we won't also be able to put in implementations for these methods anymore in the base class because they are meant to be overridden and implemented by downstream inheriting classes. So if you go in here and try to put in an implementation, we will probably get a compiler error because this is not allowed. You see, we have a problem here. If we try to build, we will get a weird compiler error. Let's make sure we see the compiler error. So build finished with errors, and we are going to see what's the problem here. Let's go up and see pure specifier on function definition. So this is not allowed. So we are really conflicting ourselves here. We are marking this function as a pure virtual function, and what that means, and a pure virtual function isn't meant to have a definition, but we are also putting in a definition here. So the compiler is going to be confused. This is not something we should be doing. Another thing I want to point out before we wrap up this lecture is that downstream inheriting classes are forced to override and implement all the pure virtual functions from the class that they inherit from. If they don't do that, they are themselves going to become abstract, and we want to be able to create objects of them. So let's try and, for example, comment out the surface implementation here, and that's going to make our circle class an abstract class. And if we try to create an object with circle, we will get a compiler error because now circle is an abstract class. Let's try and build and show you the compiler error. And this can really be confusing if you are a beginner on this. You will be wondering why you can't create objects of your class, even if you didn't really explicitly put in any pure virtual function. The reason is we are inheriting from an abstract class that has two pure virtual functions, but we are only overriding one pure virtual function. We need to override all of them. Otherwise, our class is also going to be an abstract class. Let's look at the compiler error we are getting here. Let's go up and see if we can find it. We are going to say in function, in main, invalid new expression of abstract class type circle. We are trying to create an object from an abstract class. This is the error we have here, and you should really know this. So let's go back and make sure we are overriding all these things because we need to do that to be able to create objects of a circle. And now this is going to work exactly as it should. Let's build and make sure of that. The build is going to be good. We are fine. This is working exactly as we want. This is really all I wanted you to see in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about interfaces in C++, and they are going to be reusing the knowledge we learned about in this lecture. Go ahead and finish up here and meet me there.